Hi, everyone. Good morning, good afternoon, good evening, depending on where you are in the world. Welcome to the second part of our webinar series called ChatGPT for Science, in which we're talking about how to leverage generative AI responsibly in research. Today, as you can see here right now, titled Behind the Scenes with Scite Assistant, a technical exploration, we're set to peel back the layers and reveal the inner workings of one of the most innovative tools in the intersection of AI and research integrity. Let me introduce ourselves. You might know me from the last one. My name is Julia Heeson. I'm the Director of Growth Marketing and your moderator for today's session. And today's panelist is Dominic Rosati. He is the Head of Artificial Intelligence at scite. Welcome to this webinar, Dom.
Hello.
Okay, so a couple of quick reminders here as well. Feel free to share your questions in the Q&A section below if you click on it. We'll have dedicated time at the end of the webinar to respond to all of them. But definitely feel free to add them there. We also have the chat enabled. So if you have any more of a technical question, definitely reach out via the chat and I'll be monitoring that. And then also this webinar is being recorded and I'll be sending out the webinar recording a few hours after this session is over. So if you want to rewatch any part, share it with your colleagues. We've got you covered. Okay, Dom, with that being said, right over to you.
Hi there. Yeah, so I'm on a new computer, so I'm gonna try to monitor questions if I can sort of see them, but we will have dedicated time. So most of the questions will probably be answered at the end. But I am happy for people to post questions in the chat. And so we're gonna do a little bit of a deep dive into how Scite Assistant works. Now, the one thing to note is some of these screenshots need to be updated because we've sort of done a bunch of UX things, we've released from beta and so on, and moved things around a little bit, but the principles underlying Scite Assistant all work the same. So our agenda today, we're gonna first look at the principles of factual text generation assistance. We'll look at two pieces of this that are now quite commonplace. So we'll look at a type of system called retrieval augmented generation. And then we'll look at procedures for controlling hallucinations or fabricated information with fact checking and revision. And then after we sort of have those principles in place, we'll talk a little bit about how Scite Assistant works step by step, mostly at a high level overview. We'll present some evaluation results of scite versus other systems, but this is sort of just to whet your appetite. And we'll have contact information if you want to get in touch with us later about going into any of these things in more detail. So as you might know, these technologies like ChatGPT, and now they're being sort of used and embedded. I think I saw today when I upgraded Chrome that Gemini or Google's Gemma models are now integrated in my browser. Apple Intelligence has these models as well in iPhone with the new iOS release. I think it's probably common knowledge that these models suffer from what's been termed a hallucination problem, probably more accurately, fabricated information problem. And it's not always the case that this is a problem. So say in creative or low risk tasks, but when you look at safety critical systems or systems that require correctness, such as in the scientific and research domain, you really need to try to address these factual issues. There's a variety of ways of addressing factuality and fabricated information in large language models. Many of the techniques that are used for, say, the models you're going to have in your browser or Microsoft Copilot or Apple Intelligence, they're really around training interventions. So they're really around interventions of, teaching a model that we prefer correct information and disprefer incorrect information through a technique called reinforcement learning from human feedback. But these methods are not always effective, largely because we train these models on a massive corpora of internet text that itself is not very accurate, or it suffers from things like temporality issues. So the president of the United States changes over the course of time, say, or the knowledge we have as researchers change over the time. So one of the ways that isn't a training intervention that has been proposed for addressing factuality is retrieval augmented generation. So it's a fancy word for a very basic thing, which is that your large language model, it's going to ground its text generation in some set of sources. And this is a very popular approach, of course, with scite, with elicit, perplexity, Bing. Google will now in their results shows often an AI generated results that is grounded in its search retrieval results. But scite sort of has a unique way of doing this. So there's maybe three things. One of them is that scite is the only retrieval augmented generation tool that has indexing agreements with academic publishers, meaning that we use closed sources. The sources don't have to be open access and free. We have an extremely large corpus of documents to retrieve from that has a very big effective coverage, especially in areas of research where the norm is not open access. So we have access to all of those documents. So the first point is coverage. The second point is that unlike many systems, which may use bits of full text if it's open access, they primarily, like for instance, elicit and perplexity, primarily rely on abstract or title information even, which of course you can probably already imagine is not a very effective way at getting information from publications. And since we have this advantage of, these indexing agreements, we primarily use full text information. Now, there's an additional thing, which is that we use a mechanism called citation statements, which basically shows, how other literature has talked about a certain publication. And that's key. It'll come up later to validating whether or not a source that's retrieved is a high quality source. It's been independently corroborated by other publications, what criticism might be available about that source, and so on. So this allows us to have an even more enhanced retrieval augmented generation approach for addressing the fabricated information problem of large language models. And just, to illustrate, I'm just trying to move the chat window and so on, just to illustrate what retrieval augmented generation maybe looks like in practice. It's really just, if you've heard of the notion of in-context learning. So all that means is that, say this was a prompt for a large language model like ChatGPT, you have some task. So these are going to be the things that you sort of put in the input or box in a scite assistant. So how does the structure of a protein affect its functions? And then we'll do a lot of sort of information retrieval stuff, ranking, and so on to select high quality resources, like I mentioned. And then once we do that, we'll get into that ranking and retrieval aspect in a minute. But once we do that, we have these references here. So we'll have a number of references. We'll have metadata about those references. We might have the abstract, or we might have sections from the full text of the paper. And this allows us to, produce a high quality informative answer. There are, though, a number of problems with retrieval augmented generation. So even, if you have very high quality results, say, these systems suffer from a number of issues where their citation precision can be quite low, meaning that they're citing irrelevant resources. And the reason why this happens is I mentioned the concept of in-context learning. Basically, you can reference this slide here, where we have these resources in context, and the model sort of learned how to answer this question simply using what's in the prompt. And the problem is the model's extremely biased towards using that information because it's been trained with a mechanism called instruction fine-tuning. Instruction fine-tuning biases a model to follow the instructions that you've provided it. So there's this natural bias to trust everything that's been placed in the context. And when you have a large scale system of retrieving results, you maybe will retrieve something that's irrelevant or an inappropriate source. And so a hand wavy way of talking about this is the model doesn't have critical thinking. The technical way being like uses instruction fine tuning, has a bias towards following the instructions of a user. So there's a number of ways that now we've had factuality addressed by RAG, problems with RAG addressed by two sort of different ways of thinking about things. Self-criticism, and these are, I mean, there's more than these, but these are kind of the primary ways we use in scite. So self-criticism is essentially this mechanism where it's been shown, and these sources now, were selected when we sort of first put together this presentation, but it's held true that large language models are generally able to evaluate their own answers and fact check their own answers, especially if you, again, build a system where you provide revisions or you provide additional sources for fact checking and so on. So these systems are quite good at fact checking their own answers, even better in some cases than humans are at fact checking. So self-criticism is essentially is an essential piece to fixing those problems with RAG, where you've developed, a system that might produce an output that, has some issues of irrelevant sources or inappropriate sources. And you can see that process here, right? Fact checking my answers to make sure it's correct. Hang on, this is a critical piece of how Scite Assistant works. Now, this isn't foolproof, of course, because it's a model-based evaluation system. And so because we're built on this massive scale index, giant knowledge graph or argument graph over science, that's what scite is, because we have this massive graph that shows us whether results have been replicated, whether there's criticism of a paper, failures of replication, and so on. We also can do this kind of credibility analysis where we understand the credibility of sources, and it allows us to ensure, these sources that are selected from the beginning are credible, allows us to do better self-criticism, and generally make sure the sources are appropriate. So we'll go through basically the primary, if you've used Scite Assistant before, you'll see that there's a number of steps that are done sequentially. And we'll go through some of these primary steps because it will illustrate how Scite Assistant works. So the first step is determining the number of tools used. This is just an illustration. It isn't, our tool system is a little bit more extensive than this. So basically, if you want to answer a particular research question, you have a number of tools at hand. You can sort of use search for retrieval. You could use scite reports like this criticism and supporting information, or scite dashboards for like a large library. We now have a few more of these using uploaded documents, or sophisticated table analysis, which is coming soon. And this will help you sort of decide, okay, what are the set of tools that we need to use in order to answer this question? Once we have those set of tools, I'll sort of focus on just the search case, but you can think that there's a similar kind of, let's say, planning phase that needs to happen. And so the planning phase for search if you've ever looked at Scite Assistant, you can see sort of a lot of these different settings you could set, sort of reference year range or topics and things of this nature, publication types. And this is used also with a generative plan for what queries we should use in our own search. It's very similar to what you would see in the Scite search UI. What sort of filters should we use? Should we search for like classic papers in the area and primary sources and so on? And this allows us to formulate a search plan. And that search plan is then executed. So we generate a search plan, the search plan's executed, and then we have a number of results, often way too many results that you could, well, now we have large language models like, Claude 3's Haiku and GPT-4, which are, our primary models, which have a very large context. You could put a lot of information in there. But again, remember the problem I said with retrieval augmented generation, where, these models are trained to very faithfully trust the information you've put in there. So if you have inappropriate sources, if you have this sort of high recall, low precision problem in retrieval, which is often the case when you're sort of retrieving over 200,000 or 200,000 or large scale sets of documents, you have to rank those documents and be sure of their credibility. So we sort of have a number of ranking factors. There's more than this here, having to do with journal quality, other quality metrics, and so on. But we rank sources based on things you would expect. So relevancy, recency, citation count, supporting citations. This is like an aggregate view of what the Scite index allows you to see of supporting and corroborating information or contrasting citations, so criticisms, disputes, failures of replications, things like this. And you can sort of control reference ranking yourself as an option when using Scite Assistant. So this is what the ranking step does. And this is going to allow us to have a very high signal, very high quality resources used when we do retrieval augmented generation. So now we sort of have our retrieval augmented generation piece, and you can sort of understand what's going on for selecting these references in order to accomplish some task. Right now, we do use sort of a variety of models. Mainly the ones we're using right now is GPT-4 and Claude 3, Haiku. But in the past, we've sort of used a different mix of models, and this is driven by an evaluation mechanism we use based on retrieval augmented generation benchmarks and so on. So now now we sort of get to the generation piece of the retrieval augmented generation. So we have, our retrieval piece, the augmented piece, right? The crafting this prompt. And then we need some generation piece, right? It's the answer or the output of the large language model. And so in this case, we have our composing step or generation step where, since, by the way, since we've sort of made some UI improvements, now this information of, the searches run and publications consulted are all on the right-hand side. Regardless, we'll have this composing response. This composing response will compose an answer, an initial draft, you might say, based on our in context learning that goes on here with retrieval augmentation. Oh, I saw a chat. Okay, so I'll come back to this. This requires more, definitely a lot more time. Okay, so now we have our generation piece. So in the generation piece, like I was saying, we're going to use those sources to generate text, large language models, their text generation systems. And the key piece that's different about a retrieval augmented system versus one that's not is the ability to cite sources. So let me go I'll we'll use this fact checking example, but we'll go back to fact checking in a second. So you see these sort of like 4, 2, 1. This is just using IEEE style of citation. But our default now, I think, is APA style because it's more common, but we do have a setting where you can sort of change the different referencing style for the bibliographic aspect of this. Regardless, we have our cited sources, and this is sort of like the key differentiator of any sort of retrieval augmented generation system. As you can see, what source was used. I'll show, when I get into verification and transparency, I'll show sort of how we surface this information from the retrieved sources. But for now, we can just sort of think that these are the references that were used in context that the model learned from and learned to make citations. So like I was saying, there's sort of this key fact-checking piece. And we have these two, like we have model self-criticism as well as credibility analysis. But the fact-checking piece here, it's a very common approach for model self-criticism, where essentially you have a prompt and you're placing the model in this kind of mindset, you might say, where and this is just a demonstration case because there's a little bit more complexity here, but you're sort of giving it instructions on how to make revisions, what kind of personality to simulate. So here, sort of an editor for a journal or a peer reviewer potentially, and instructions on how to do various things like removing inappropriate citations, checking any factual errors against, again, an additional sort of retrieved set of sources and things like this. So that's what's going on in the fact-checking case. The percentage should be variable to control hands over, very disturbing. Text is only seen, presentation. I'm not sure I understand what the question is, but we'll go back to the end. Yeah, I'm not sure what that is. So fact checking, again, is this process here I talked about before, where we have this prompt, we have our fact checking, and the fact checking, this is what it looks like when you're using Cite Assistant. So this is, again, going back to these principles of factual natural language generation using self-criticism. I'm not going to go into too much details about our credibility analysis and so on using leveraging Cite index, but just because it's a lot to get into, but you can sort of think of it as using this giant argument graph over like replication, information, corroboration, things like this for enhancing model self-criticism and source selection and source use and so on. And so a big part of our retrieval augmented system is this transparency and auditing perspective of understanding, what searches were run, what publications were consulted, what publications were used, what part of each publication was used, and so on. And the UI for this has changed a tiny bit in the current iteration of Cite Assistant, but essentially, this part is the same where, if you hover over these in-text citations, you can see what part of Cite Assistant was used, or what part of the in-context reference was used, what part of this reference was used to answer this question. And this is done for all of the in-context citations. And also on the side, you can sort of see, what information was used in order to generate that information. And so like we make no claims over perfect factuality. No one can do this. When you use large language model systems, they're always limited by the fact that, large language models fabricate information. The only thing you can do is like control this as much as possible. So we try to make the experience of verifying answers as easy as possible. And this includes both being able to check information retrieved, but also more importantly, being able to sort of click into these Cite reports. So you can see this sort of badge here that has, the blue question mark, which is a piece of a contrasting citation, so potential criticism of this paper, be able to click into the source and read how's that source cited, what are its criticisms, things like this. And that will allow you to understand better sort of, whether this will, for yourself, validate whether this information is warranted to be used, and the appropriateness of this source, which is a key piece to Cite Assistant. Just a little bit in terms of valuation perspective. So, naturally, ChatGPT generally doesn't sort of provide these external citations. So we're going to use a system called RAGS, and RAGS allows us to evaluate retrieval augmented generation experiences, and we have a number of scores. So the RAGS score is going to be an aggregation of these various scores. Harmfulness is what you would expect. Correctness is using a larger model, so as large as possible model as sort of an oracle of whether the answer was correct given a number of in-context sources. Context relevance is whether or not well, first, it's actually easier to explain. Answer relevancy is whether or not the answer is relevant to the question you had, whereas context relevancy is whether or not the sources selected are relevant to the context you had. And faithfulness is whether, for the retrieved sources, your model is generating exactly faithful or, it's staying very true to the original intent of the authors in those retrieved sources. So we just sort of have two baselines where there's ChatGPT, which of course in this iteration, it doesn't retrieve its own sources. So of course you can't have, faithfulness or context relevancy, but you can see a model with, and this is 20 questions from systematic reviews. You can see a model with out retrieving information, its correctness is quite low. These systematic review type questions can be quite sophisticated, so they're very much in line with other research tasks you might have. RAG using Crossref. So Crossref is this open academic metadata system. So this would basically be, if you built a free version of Cite and you didn't have these indexing agreements, you only had access to sort of searching over abstracts, then this is sort of the score you would get. Yeah, again, also without doing fact checking and things like this. And your RAGA score is quite low, again, because you're not able to retrieve as relevant sources for your original question. You're not able to maintain sort of this faithfulness because you have these maybe potentially competing sources of information or relevant content selected. You have context relevance issues, again, having to do with what I just said, and resulting in, a number of correctness issues. And you can see for assistant, we sort of like very much heavily weight things towards this correctness aspect because we're trying to produce a product that's usable in the research domain, of course, given the limitations, the natural limitations of using large language models. But this is sort of how assistant compares to other systems you might use. I'm gonna skip over this section just so we can get to questions, but it's essentially to show we had a number of manual raters from different domains. Here's this systematic review domain just on sort of the relevancy of our retrieval mechanism and how it was selected. So I think I'm passing back to Julia at the moment. Yes, yeah.
Yes, thank you so much, Dom. And thanks everyone for the few questions that we already see. If you haven't added them yet, you can do so now. But before that, if you like what you saw today and you would like to either try Cite or Cite Assistant firsthand or ask for a demo, invite more people on a call, I'm adding a link in the chat right now, so you can just head over there. Cite does belong to Research Solutions. Just wanted to call that out. And then I'm adding another link, and this is directly to Cite Assistant, and you have two free searches. So if you want to test it directly with that second link that I sent in the group chat, head over there and try it out yourself. And then also on that website, you'll be able to reach out if any additional questions come up that maybe we don't get to right now. Okay, let's head to the questions.
Yeah, so I'll take the first question. I mean, I think people can generally just ask questions as we go, and then I'll just answer them. So yeah, so the question is more around, at any level of ranking or qualification of an article, is any of it done by humans, or is it sort of only done by machines? And the key piece to cite is that we are relying on this human metadata that has been produced about documents. So these are things like, the first of all, it's a human that chooses whether or not to cite another article, right? So the citation count index, or the citation count ranking signal, let's just say, just to use a simple case, is a human signal, right, for ranking. Another one would be, we're using the text of other authors, who have cited a paper, to understand what is the criticism of this cited paper, what are the supporting evidence or corroborating evidence, how is this paper typically used, things like this, and those are all human interventions that are used. Wish for the slides. Yes, we'll provide the slides afterwards. Do we have a French version? So the short answer, okay, the short answer is there isn't a short answer, unfortunately. So in terms of like multilingual usage of Scite Assistant, it will work by default in whatever language, as long as you do that prompt in that language. So if you do a prompt, if you ask Scite Assistant a question in French, it will provide a response in French and be biased towards using French resources. Now, it's a slight bias, right? It will, if it's more relevant to use resources as in another language, those will be used. The caveat is, though, in terms of just basic internationalization of our user interface and so on, by default, that's English, so you'd have to use some sort of tool for internationalization, but our web page is made friendly for this kind of purpose. So certainly, like a Scite Assistant is multilingual. A number of social sciences have a problem of construct proliferation. So, okay, yes. Yeah, I would say, it depends on, so the question is for having different constructs or, mental models or frameworks or formulations or formal analysis of the same phenomena using different names. How does Scite Assistant help in identifying issues with this? The first one is you can think of the problem being, if you have a number of constructs that have different names, as a human researcher, if you don't understand that something has one formulation, something has another formulation, then you're sort of only going to do literature review using the keywords in one formulation. And so if you think about that problem of, construct proliferation, then, Scite Assistant solves this in the planning phase, where we explicitly do try to have a planning phase for as diverse as possible literature review. This kind of presupposes that the model itself is able to deal with construct proliferation. But, in practice, we do see this. Say, I'm not in social sciences, I'm in computer science. So say, you had something, a notion of training stability or something like that. There's construct proliferation for that, because in control engineering, you have, stability in terms of control, and in optimization, you have different ways of thinking about that. And so we do observe, the planning for search often does retrieve those different constructs. But I would say, like, there's also a different separate problem of, can Assistant help in identifying the issues? Like, say you were a researcher on construct proliferation, and you wanted to use Assistant for, identifying what are these sort of core formulations that might be different, and that is like a use case that researchers can use Assistant for. Those ranks are based on citations to academic writings. As users, how can we overcome these faults? I think, okay, so I think in terms of the way I'll sort of try to understand this question is that if you look at, let's say, just different quantitative metrics over research, so these could be citation counts, these can be things like journal indexes and so on. They have some bias in them, of course. So, the popularity bias, right, of having a citation that's highly cited, it's going to be continually cited and so on, and how I'm not sure how, as users, you would need to overcome the faults. You might be able to use like the different ranking signals, or to control ranking according to sort of something that's more relevant to you. We see this a lot where in certain biomedical fields, researchers need relevancy to be, or recency rather, to be quite high. So, you really sort of need to restrict the year ranges and so on. So that's like one way a user would. But of course, like I mentioned, this diversity in search planning where, ranking signals, they can't be the only thing you use. So if there's something that's sort of has a low citation count and is from a journal that's sort of not very popular, of course, if it's the most relevant thing, it will be used. Is the list of your partner publishers available? Yes. So on the scite.ai website, there's at the bottom, there's a link to data and coverage, and it has like a list of all of those things, or it should, yeah.
I'm adding the list in the chat right now, so feel free to head over there.
Yes, great. Perfect. Are there any other questions?
Yeah, I see one in the Q&A here. Can you add
yeah.
books of your own choice to the search?
Oh, I didn't realize there was a Q&A. Sorry.
No worries.
Can you add printed books? So this is what I'd say, like, this is definitely one of the weaknesses, let's just say, of scholarly infrastructure in general, scholarly communication infrastructure. So, books are monographs, printed books are much more challenging. There's a number of reasons why this is, DOI adoption, and for journal articles was much faster, things like this. But certainly, like, our monograph printed book collection is much smaller. So there's fields, that maybe rely potentially on books, let's say mathematics, for instance, where we would have lower coverage. That's changing now, where chapters tend to be like our primary unit of analysis. So for in the scholarly communications ecosystem. But I'd say for just this notion of, can I add some content of my own for Site Assistant? Yes, that's what uploading documents are for. So where can you add these in the settings? So there's this, I am sharing my screen, right? So if I do scite.ai and I go to Assistant and I go to Sources and I select Upload, then I can sort of upload, say I had, a textbook or something like that, or like a small monograph on, convex optimization, something like this. Then I can add that there. So I think that answers the question, yeah.
Awesome. I see one more here. Oh, sorry, go ahead.
Oh yeah, does Site Assistant use short-term memory? I mean, I think it depends on what's meant here. So there's like a notion now that's well, we'll get to the next question after. There's a notion now of using memory in some of these systems, because these large language model producers are not always transparent about what that is. It's not entirely clear what is meant by this like memory system, certainly, though. And so there's sort of like two ways of potentially thinking about what was meant by them. One is like across all of your, let's say in ChatGPT, across all of your sessions, there's some sort of like summarization of the kinds of things you ask for and prefer. Um, Across all sessions, we don't have some sort of memory system like that, but certainly within, say, your, assistant transcript. So I'll just pull one up of these. Well, I don't have like a multi-turn one, but if you add follow-up questions, add more terms, certainly, what's used before is referenced. And so in that case, there is memory notion. Yeah. So I cannot upload printed books. This might be something that you should email into our support for, because it should be the case that in terms of you don't have. I think maybe okay. So if you do have the PDF, then yeah. If you can't do this, this would have to be something you'd contact our support for, because we should be able to do for PDF. If it's a printed book and you don't have the PDF and you want to use the source, well, then it's the same. It's just a coverage issue. So, if you want to use a particular paper, I mean, we call it papers, but it could be sources, and you want to find a monograph, like I can't really think of one. I was like looking at Nesterov's introduction to convex optimization this morning. And yeah, I'm not sure we'll have it or anything, but yeah, if you put in the source, you can sort of see if you can find it, or you can use the DOI. So that would be the way that you would add a book that, say, is printed. Of course, it would have to be digitized, right? It would have to be digitized. It would have to be have a DOI. These are the kinds of problems I'm talking about in the lag, let's say, for monographs and in the scholarly ecosystem in general, right? It isn't a scite problem in per se. It's a problem with the scholarly communication ecosystem.
Hey, I see one last question, which is, what do you, Dom, see as the biggest advantage of using scite?
Yeah, so I think the biggest advantage for using scite, I'll sort of like, maybe I'll give two things. Like one is my personal one as like a computer science researcher, and the other one would be like, what do we see as the main use case? Um, my own personal one is that there's like a whole set of tasks that you do as a researcher that are discovery tasks. So there are things like um, trying to find out, like in my domain, it's sort of like trying to find out if someone had used a particular proof technique or theoretical analysis for something, or whether or not there's been some comparison, or these kinds of things that are like very difficult to formulate as a literature review, or just like doing sort of backward chaining or forward chaining through citations to find out. It would take a lot of time. It really gives you, it's almost like going to an advisor or a senior researcher, posing a question and getting this sort of like very tailored data dump, and that sort of jump starts your quest. I think many of us as researchers have this experience of like going to a senior researcher and then getting something it was very hard to get from a literature review. Now, for the main use case, I think people often use, and I mean, it's similar to this main use case for ChatGPT, but like the types of things you would need references for. So it's often drafting, right? It's sort of like, I have a draft and I want it sort of rewritten in a particular way, or I want to start constructing a draft for some scientific artifact. It could be slides, it could be a poster, it could be writing artifact, grant, things like this. So being able to do those from outlines and so on. Okay, so what do you consider as the main limitation? I mean, the main limitation is the factuality piece with like I'd say like the main limitation for all of us working on large language model applications is the limitations of large language models themselves. So it's really trying to build like robust systems with guarantees on factuality. So, we just, all we're doing, right, is just trying to approach that as much as we can, but there are certainly limitations there. Beyond that, I think there are concrete limitations, that are just part of our, let's say, product and research development, which is sort of, coverage issues. So yeah, monographs, for instance, is one where we really want to improve on, or data sets, or things like this. So, coverage is basically like one of the main limitations, where we're very good at coverage in some disciplines, and other disciplines, or often now it's not so much other disciplines, but it's often, let's say, certain research tasks where, yeah, data sets is probably a good example, where, we will be able to retrieve information about data sets, right? The papers that surface data sets or use them or crafted them, but not necessarily the data sets themselves. So that kind of like numeric reasoning certainly isn't available. So yeah, I'd say that's like probably that's the type of main limitations coverage. Yeah. There's a question here on how do user testing concerning user interface, regular testing, what have you learned so far? I mean, this would be sort of more on our like product and QA team. I'm trying to think. So, I mean, yes, regular testing all the time, every day. We like continuously deploy things every day. So, those are tested as they're released and so on. I mean, I guess one of the things learned, you'll see, I mean, the only thing I think maybe that's useful here that I could think the top of my head is that you'll see this sort of across different tools like Elicit and Perplexity and ChatGPT and Anthropic and a Site Assistant. They sort of like independently converge on a very similar user interface. And so the thing, is that it's a common set of learnings of how you interact, how you construct like an assistant type experience. Um, and these, I mean, probably the main thing we've learned is basically from feedback from customers, which is like, transparency, verifiability is the most important thing, because people understand by now, people understand the limitations of large language models. Like no one's expecting perfect performance, right, of these things, but they are wanting these experiences of verification. So I think that's probably the biggest thing learned so far. There's another question here, like, what is the field of academicians who conduct such research on large language models? Well, I mean, primarily this is like in computer science, right? This is natural language processing, which is my field, where, not only do we construct these models, right? Do research into how you do language modeling, right? How you model language understanding and things like this, but also uh, theoretical analysis of like what are the limitations of how these systems can learn and perform, but also empirical analysis of how they behave. Like what are their limitations on the behavior? What kind of, let's say, benchmarks we can construct to elicit certain types of behavior, like retrieval augmented generation, like factuality, things like this. I'll just like end this question with, so yeah, natural language processing is sort of the home. Uh, and Association of Computational Linguistics is sort of like the institutional home of this. But I'd say, within the social sciences, we certainly see a lot of interest for partnership over evaluation, and in the biomedical field for sure. So you'll see tons of evaluations now that are usually some collaboration between, a set of doctors or something on understanding sort of large language model competencies in some medical task. So here's another question. In any work done to improve potential use for systematic reviews, which have high level of search transparency required? Yes. So there, I mean, it's a little bit complicated, as you probably would know, given you're sort of surfacing things about systematic reviews. Our main primary focus is trying to, right now, it's not the case, but it's something that's in active development that hopefully we'll be able to release in the new year, is being able to satisfy auditing requirements like Prisma or other systematic review auditing requirements as best we can. Now, there's some you can't, right? Like these systems are not deterministic. They will retrieve different sources every time. They'll give different answers every time. You know, they might be similar, but there's just natural limitations that will never be able to be changed with that. That make being able to comply with some of these systematic search auditing like in certification stuff more difficult. But certainly, let's say one of the things we're imagining is being able to have like a Prisma compliant, you know, set of searches and things like this, where we are trying to make people who do systematic review, you know, it fit a lot closer. There's some other things in terms of high recall that we will be releasing very soon around one of the things with systematic review is sort of there's a generative AI natural flow where you have used this other tool for having your extremely high recall retrieval of tons of sources, right? You have the sources and you want to do filtration or, you know, assessment of these sources themselves. And we do already have this structured response view, but we'll have I could probably show a little bit just of, I'm not sure it's going to be here. Oh yeah, it's not going to be on this account, but I think we're going to send out an email soon, basically showing this experience that if you're a systematic reviewer, you could sort of say, these are the papers I want to do this task on, filtration or something like that. And you'll get sort of, you know, rows and things like this that assist you with that task. But the Prisma stuff will come later after that. From the list of publishers, there's not listed two, also big one, Springer and Elsevier. You don't have articles from these publishers. So I can't speak to Springer because it's confusing that I know for a fact we use Springer Nature, but like I think there's another Springer and so on. But Elsevier, certainly we don't have an indexing agreement with. And like all that means is that for the articles that are closed for Elsevier, and I mean, I do think we have coverage with Springer, but it might just be Springer Nature. I'm not exactly sure the difference between the two, but say it was Springer and Elsevier. There are others we don't cover, we'll have indexing agreements with, right? And so it would mean that for these publishers, we would only have the articles that are open access or only have their metadata. So, you know, we would have the abstracts of these systems, unless they're sort of like very restrictive, or papers, unless there's very restrictive copyright or things like this. And we would be able to answer over only sort of the open access ones of these. So it wouldn't mean we don't have the articles, it would just mean we don't have closed access articles for ones we don't have indexing agreements with. Yeah. And then there's a question. So model means a system that functions to handle a specific issue. Yeah. So, I mean, the model part in large language model, right? It's a model of language. It's a probability distribution over, to make it simple, words. They're word pieces, but words, and whether a word occurs after another word. So that would be, you know, the model part in large language model. It's just large and it models language as a probability distribution. Yeah.
Hey, amazing. Many questions. I love it. This has been awesome. I know sometimes questions come up afterwards. So with that link, those links that I sent earlier, if any questions come up, feel free to reach out. We have a help topic as part of the form on that page. So feel free to reach out afterwards and be happy to take any questions later. For now, Dom, thank you so much for presenting and answering all these questions in great detail. Thank you everyone for joining this live webinar and spending this hour with us. We hope that you left with many more details about scite and how it works. And yeah, really hope to see you on the next one.
Thank you, everyone. Bye.
Bye.